Okay, so I need to record this. Is gravity a force? How do you explain that question? Okay, most of you guys came up with some interesting answers normally. If gravity is a force, that's the reason why we're not floating, blah, blah, blah. That's not what I'm looking for, obviously, right? What I'm looking for is that a force? Well, what's the definition of a force? Okay, somebody said something. I'm gonna take a look. No, gravity is not a force. Okay, so obviously if you answer it like that, Jordan, give yourself 5 points. That means that you end up getting yourself 0.25 out of 2 points. Is gravity a force? Of course it's a force. How do we know? What is a force? Force causes acceleration, right? So falling objects, do they accelerate? The answer to that question is yes. So which means that gravity is a force. That's what I'm looking for. Concise explanation. And some of you guys, most of you guys are okay, but some of you guys are still writing some interesting stuff. It's almost like poetry. Oh my God, I believe it is. All right, guys, it believes in emotional commitment to an idea, whether it's right or wrong. Okay, so your belief has nothing to do with this. So what I want you to do is justify it. Is gravity a force? Yeah, because it is. Falling objects do accelerate, right? And what causes acceleration is a force. It's in the same direction. So is gravity a force? Absolutely it is. Because falling objects do accelerate, so which means that there's a force acting on. That's the answer I'm looking for. So does gravity extend all the way out to the moon? Of course it does. How do we know? All right, there are two answers. Both of them are acceptable. One of them is more acceptable than the other one. Okay, so one answer is if it didn't, what would happen? Moon would have gone in a straight line at a constant speed. All right, so that's good enough for 1 point. Okay, I'm looking for a better answer. What's missing is, yes, gravity is extending all the way out to the moon because the moon is accelerating, right? What causes acceleration? Force does. So a moon is accelerating in this direction. That implies that there's a force acting on the moon. That's it. All right, so you can make two arguments. One of them is partially correct. And if gravity were not a force, moon would have gone in a straight line at a constant speed. That's the Newton's first law. And because the moon is accelerating, how do we know that it's accelerating? Number one, it's changing direction. And number two, if you're inside a car going through that kind of motion, you will feel a push in the opposite direction. So implying that the acceleration is directed inward towards the center, right? That's what I'm looking for. All right, so that's a complete explanation. It's accelerating. The acceleration is caused by a force. So which means that gravity extends all the way out to the moon. All right, Jordan, give yourself 5 points. That the gravity is an attraction of two masses. Okay, we haven't covered that. Yeah. All right, so I'm not interested in what you guys really think or believe or whatever. Just stick to the facts, guys. When you put the facts together, the answer just magically appears. That's called science. All right, so the head-on collision between a car and an SUV. All right, so which one, if any, experiences a large impact force? Which one is going to experience a large impact force? All right, if you go with your common sense, I mean, if you're completely clueless, if you're missing the lectures and thinking, oh, this is a really easy course, you're getting an A, and then you start checking your grades only to freak out that there's a mistake somewhere because your answers are so concise and precise. You answer everything yes and no, and then you go, oh, it's obviously that the car is the one which is suffering the most damage. So if you're doing it that way, your way, then good for you. So obviously this is not working out for you, because it just so happens, and hopefully this is not the first time you're hearing it, because I've said it like a million times. Which one experiences a large impact force? Both, because Victor said, give yourself 5 points, Victor, because it's because of Newton's third law, which means that for every single action force, there's going to be an equal and opposite reaction force. Okay, so you could say both will experience the same force. You could say both, I'll give you half a point if that's a complete sentence. Or you could say both of them will experience the same force. That's like one complete sentence. Because of Newton's third law, I will give you 1 point for it. Now you have to explain the third law. What does it mean? According to the third law, for every single action force, there's going to be an equal and opposite reaction force. Action and reaction forces will be equal, and they will be in opposite directions. So reaction force is the same as the action force. It's going to be in the opposite direction. All right. The next question is the same as question number 3. This time, the person is getting hit by a train, 500,000 pounds of force. Does the person apply the same force back on the train? The answer to that question is yes. Once again, just like here, action and reaction forces are the same in opposite direction. But there's more I'm looking for. Where's the evidence? All right, so where is the evidence that the person applies the same force back on the train? Okay, I get some weird answers like, oh, it's the third law. Well, third law is not an evidence, guys. It's just a statement of fact. Okay, so where's the evidence? According to the third law, this person should apply the same force back on the train. And if this person applies the same force back on the train, there has to be some evidence. All right, so there's no evidence. There's no evidence. Okay, so I need more. Then there's no evidence. Okay, it is true that there's no evidence. Now you have to justify why there's no evidence.
There's no evidence because the train is so much bigger than the person, and it's made of a different material.
Okay, so out of the two statements that you made, one of them only relevant in terms of
One's so much bigger than the other.
yeah, that's it. That's
Yeah,
it. That's
one
the only
point.
thing I care about. It different materials. That's fine. So the force is the same, right? Give yourself 5 points for that one. So it's the same force. They're sharing the same force. So the train is so much more massive, right? It's not that it's bigger, it's just so much more massive, which means that the acceleration is going to be so much smaller. There's evidence, but the evidence is just a simple vibration. Does the train ever vibrate? All the time. All right, so that impact, 500,000 pounds of impact force acting on the train is not going to cause a noticeable acceleration. So you won't be able to see it. You won't be able to notice it. All right, so the con, it's not blind faith. Your faith has nothing to do with this. Facts, my man, facts. All right. So crash testing at 40 miles per hour. You know the occupants will move in the forward direction, right? In the opposite direction of the acceleration of the vehicle, right? Why? So what's pushing these people in the opposite direction of the acceleration of the vehicle? Nothing. People are just maintaining their initial motions. So the occupants keep on moving. Inertia, give yourself 5 points. So now you got to explain it. Inertia, in the absence of an external force acting on the occupant, they're just going to maintain their initial motions, which means that they're going to keep on moving in a straight line at a constant speed because they got mass. They got that tendency from their masses. All right, so that's a complete statement.